So let's have a look. So why don't we go ahead and look at the producer surplus question to start. So producer and consumer surplus are pretty similar formulas. So let's start with number 2. So the producer surplus that's given by the formula, the integral from 0 to 0 to capital Q, I believe. And then we've got the supply function. So the supply function, I think this is going to be S of Q minus P. Sorry, my computer's lagging a bit. S of Q minus capital P dq. So they give us the quantity, so we find capital P. So here we have S of Q is equal to 24 e to the 0.003 q. So the decimal place is here. And we're given capital Q is 600. So first thing is we want to find capital P. So capital P is what we get when we plug in 600 in for Q there. So we get e to the 0.003 times 600, and we want to plug that into the calculator. Again, we'll round a bit, so let me go ahead and do that. 24 times e to the 0.003 times 600. So I get something like 145.1915. Hopefully that's enough spots. So what we want to do to get our producer surplus is plug that stuff in. So we get the integral from 0 to 600 of this 24 e to the 0.003 q minus the 145.1915 dq. And so the derivative is going to be 24 e to the 0.003 q over 0.003 minus 145.1915 q from 0 to 600. So let's see what we get. Let's plug in these both into the calculator. 0.003 times 600 divided by 0.003 minus 145.1915 times 600. So I might have done this backwards. We'll see. I'm getting minus 38,717.72 minus you just let me go back and make sure I did the formula right. So 6.2. I didn't mix it up, did I? So the first one, there's the consumer surplus D of Q minus P. All right, so it should be P minus S of Q. So I got it backwards. P minus S of Q. But still, that should only be a so I got this backwards. It should be P minus S of Q. The supply curve is increasing, so the constant should be on top. Okay, yeah, so that's all that's going to do is it's going to make this positive. So this would be negative and this would be positive. Okay, and then I think this is minus. So if I did that right, I should get minus 24 times e to the 0.003. Oh, that's e to the 0, so that's just 1 divided by 0.003. Okay, so minus 8,000. So this should be my answer. So that should be 30,717.72. So hopefully that comes out as the producer surplus. Yeah, if you end up doing one of these wrong, the producer or consumer surplus, and it comes out negative, you probably just got the order wrong like I did. So the producer surplus is P minus S of Q. The consumer surplus is D of Q minus P. Again, if it's negative, typically, though, it's just the opposite answer. So it says round your answer to 2 decimal places. So hopefully we're accurate to that. $30,717.22. That makes sense. Okay, so I messed something up here. Let's plug it into Desmos real quick, just in the interest of time, and see if I'm far off or not, because I don't want to spend a lot of time if it's just a small decimal error. So we were trying to do the integral from 0 to 600. Say 145.192 minus, and again, this all needs to be in parentheses. I'm going to use X rather than Q. 24 e to the 0.003 x ex 46,718.02. So let's check that, and then we'll go back and see if try and find where I made my error. Okay, saying that's wrong too. So one thing to check, did I plug my 600 in wrong? So 24 times e to the 0.003 times 600. I'm getting 145.192. So that's my sales level. I plug in Q, I get capital P. That should be right. So I've got that. Let me add a couple extra decimal places to make sure that doesn't change the last 5391. Okay, so that does change it to 46,718.34. So maybe that was the problem. I just didn't use enough places. Oh. Okay, so minus 24 times e to the 0.003x to the 600. So what's gone wrong here? Oh, this should not be a 2. This should be a 1 because I rounded. Okay, so 46,717. Okay, so hopefully that's the problem. I punched the wrong number there. 0.74. Okay, so now we got it right. So it's completely a rounding issue. We just had to use enough decimal places there. So yes, to round a 2 here, I typed in, my calculator gave me something like 7 decimal places, so I typed them all in. So it's very sensitive on this one. But did I make a mistake in the integration somewhere? Yeah. So I just, this should have been a plus. It was minus a negative, something like that. So if this is a plus, we get the 46,000. 46,717 0.74. So if you use more decimal places, this comes out to 74, not 72. So apologies, that was the error there. So not enough decimal places, and then dropping a negative in this. Let me just make sure that makes sense. So yeah, it should be P minus S of Q. So, P minus S of Q.
Professor?
Yes.
How did you put an integral in on Desmos?
You just type INT. So if you type the letters I and then T, integral appears.
All right, thank you.
There's probably a way to actually get if I click this keyboard icon, and then click functions, I don't know, miscellaneous, it's also here. But a lot of times these functions have just commands that you can type. So I've just typed INT for so long it comes up. All right. Okay, so that one didn't go so smoothly, but hopefully the next two do. Okay, so let's have a look. Let's say, all right, let's do 3 and 4. So number 3. It's a future value problem, I think. So remember the future value formula is FV is equal to e to the RT times the integral from 0 to capital T of f of t, where that's your annual amounts, times e to the negative RT dt. So it says the retiree is paid 1,800 months per month by an annuity. So F of T is the annual amount. So that would be 1,800 times 12. So if you do 1,800 times 12, you get 21,600. So that's what we're actually looking at here. It says if the income is invested and earns 5%, so our little r is 0.05. And they want us to figure out the future value after 10 years. So that's capital T equals 10. That should be all we need to do this problem. So if we plug all that stuff in, our future value should be e to the 0.05 times 10, integral from 0 to 10 times 21,600 times e to the negative 0.05 t. So we have e to the 0.5 times 21,600, and then the antiderivative is going to be e to the negative 0.05 t over negative 0.05 from 0 to 10. So we've got this 21,600 e to the 0.5 times e to the negative 0.5 over negative 0.05 minus 1 over negative 0.05. And let's see what we get there. Hopefully I don't have as many difficulties with the calculator this time. So I'm getting 280,247.59. So hopefully that checks out. So 280,247.59. Still 2 decimal places. Okay, all set. So we did better there. Number 4 is a present value. So if you remember, again, these formulas, you can look all these up. I think I typically remember them okay, but you know, they're in the notes if you forget. The present value should just be the integral from 0 to t of e to the negative rt, f of t times e to the negative rt dt. And again, I think that's in the notes. 6.2, second part maybe. So there's future value. The second topic with income streams. There we go. There's the present value formula. So present value 0 to t, f of t, e to the negative rt dt. So we have the right formula written down. So let's get the info from the problem and go from there. So it says the winner of a $5 million lottery is paid in annual installments of $250,000 for 20 years. So I suppose that means your f of t is 250,000. And your capital T is 20. The winner estimates he can, so this is going to be our little r, 7% annually if you invest it. So r is 0.07. So we're trying to compare this to a cash value payment of 2.25 million if he takes the lump sum at once. So the idea is maybe you it seems like you get less money if you take the installments, but if you're smart about investing it, can you actually make more money than the lump sum payment and present value if you're investing this intelligently? So that's what we're trying to figure out here.
Professor,
Yes.
where'd you get 25? Never mind. I thought you said 20,000.
Excuse me?
I thought you had said 25,000. Never mind.
250. I might have misspoke. Should be 250,000 for 20 years. So basically, we're going to see if our present value is bigger than this number, 2.25 million. So the numbers we're using are just the 250,000 is the F of T. That's the annual payment. Capital T is 20 years, and little r is 7%, or 0.07. So plug that stuff in. So our present value is integral from 0 to capital 20 of 250,000 times e to the negative 0.07 t dt. Oh, I'm trying to think back to, never mind. Sorry. Okay, so then we integrate, so it's just 250,000 e to the negative 0.07 t divided by negative 0.07 from 0 to 20. We want to plug this into the calculator. So I get $2,690,725.13. So this amount, this present value, actually looks like it is beating the, well, I guess I don't need. It looks like it's beating the lump sum payment in today's dollars. So it's not that this is, if you invest it in today's dollars with the payment plan, you're actually earning more in this scenario. But again, that's under the assumption that you can make 7% investing it per year. So no, he should not choose the one-time payment. And that amount is, as we said, 269,725.13. Okay, so also there on number 4. Now we just have a few differential equations to go through. Again, we'll skip over number 5. That looks like one of the easier ones. We'll look at number 6 to start. So we have dy over dx equals 3x e to the minus y. So again, this is dy over dx equals 3x over e to the y, if that helps you think about it. Then basically you want to cross multiply. So you have e to the y dy is equal to 3x dx, and then we can integrate. So we have e to the y is equal to 3x squared over 2 plus a constant. So I don't know if it will accept this or if we have to solve for y. So let me try and enter it like this and see if it takes it. I cannot remember. Let's see. So it didn't take it that way. So let's go ahead and try and solve for y. If you solve for y, you're basically just taking the natural log of both sides. So we get y is equal to the natural log of 3x squared over 2 plus a constant. And the trick about this is, remember, if you have it takes sums to products, or it takes products to sums rather. So let's try entering this. Sometimes it wants you to write the log a little more creative, or the constant a little bit differently. I'm just trying to remember how to do that. I don't know if it's just one of those cases. Okay, so I just wanted you to solve for y. So we just had to take the natural log of both sides, and that was it. So nothing too crazy there. Let's go ahead and do number 7 as well. So we have dy over dx is x plus 4 over y minus 4. Again, essentially, you're just cross multiplying here. So you get y minus 4 times dy is x plus 4 times dx. Integrate both sides. So you get y squared minus 4y equals x, y squared over 2 equals x squared over 2 plus 4x plus a constant. Yeah, so how would you solve this one? Does it really want us to solve? So I'm going to try this again, y squared over 2. Oops. Minus 4y equals x squared over 2 plus 4x plus a constant. This one, it's not so easy to solve for y. We'd have to use a quadratic. See, so that's the thing. On the one hand, they make you solve for y in number 6, but they don't in number 7. I don't know why. Could you do it? You could, but you'd get 2 separate curves, because when you solve a quadratic like this, you'd end up with a plus or minus in terms of x. So, I don't know. Whenever I did written in-person tests before we went to coronavirus, I would always let you stop before. I wouldn't make you solve for y explicitly. It's not necessarily the case that y is always going to be an explicit function of x. In number 6, it is the case. In number 7, it's not. Okay. Number 9 is actually very similar to number 6. We're not going to do that one. So we'll do number 8 and number 10 for our last two. So for 8, find the equation of the curve that passes through 0, 1, whose slope at xy is 17xy. So when they tell you the slope is 17xy, that's giving you a differential equation. It's telling you the rate of change dy dx is 17xy. So what you end up with is 1 over y dy is equal to 17x dx. When you cross multiply, moving the y's left and the x's right. So we get the natural log of the absolute value of y is equal to 17x squared over 2 plus a constant. So if we want to solve for y, our curve here, we would exponentiate both sides. E to the natural log of y is equal to e to the 17x squared over 2 plus whatever this constant is. So that's our function y is equal to e to the 17x squared over 2 plus this constant. And now the point is we want to plug in 0 for x and 1 for y to figure out what c is. So 1 for y is equal to e to the 0 plus this constant. So 1 is equal to e to the c. So the natural log of 1 is equal to the natural log of e to the c, which tells me natural log of 1 is 0, so 0 is equal to c. So that means if you plug this back in up here, we actually just get y is equal to e to the 17x squared over 2. So this is our curve. So that should be it for number 8. Y equals e to the 17x squared over, squared is in the wrong place, over 2. There we go. So that does the job for number 8. Let's go ahead and look at number 10. Doesn't look so difficult. Just solve the dE. So number 10, dy over dx equals y over x. So we get 1 over y dy equals 1 over x dx. Integrate both sides. We have the natural log of the absolute value of y equals the natural log of the absolute value of x plus a constant. So you could again exponentiate both sides. E to the natural log of y is equal to e to the natural log of this absolute value of x plus a constant. So we get y is equal to e to the natural log of the absolute value of x times e to the c. So just remember, what am I doing there? I'm basically just using the fact that this is because, right, if you had, I don't like the periods. So this is because e to the a times e to the b is equal to e to the a plus b. So this natural log of x plus a constant will be the same as the e to the natural log of x times e to the c. And because e to the c is arbitrary, we could rename it by an arbitrary constant as well. So I can actually just call this c times e to the natural log of x. So that's a trick that's used often with arbitrary constants. This is since e to the c is arbitrary, comma c is arbitrary. And technically, we could at least say that c has to be positive because e to the c would have to be a positive value. I'm a little bit curious if this is what they want in this form. That would be my guess. E to the natural log of the absolute value of x. Yeah, so it took it like that. I'm curious, what if I did e to the c times that? I wrote it like this. Would it accept this as well? Yeah, so it accepts both forms for number 10. You don't have to do this last trick where you rename e to the c capital C, but in differential equations textbooks, it's the common way to kind of write it. Anyway, so I think that's about it for the homework, unless there's any additional questions from anyone. So sorry about that first one, but let me end the recording.